as Elysa. I'm going to butcher it.
It's fine.
Smigielski, sorry, from SUNY ESF. Yes, I'm getting a ride home with as well. So by the end of the trip, I'll be able to pronounce your name, I'm sure. So the floor is yours.
Thank you. I'm a master's student at SUNY ESF, so I'm here to present just a brief discussion about my master's project, and this is mainly just the ArcGIS component of it. So my research question is looking into, do property values increase when a neighboring state forest is in view? My study area, it compromises Portland, Tioga, and Tompkins counties in New York. So just a brief review of the literature, very brief. Value of a forest view, that was the main thing that I had to look for. Prudial, ETAL found that yes, that when you look at views of forest landscapes, they are positively correlated with property values. So going from there, then I looked at richness of view. Sander and Pulaski calculated the percentage of different land cover classes within each view, essentially looking to see if a small percentage of a desirable landscape like forest or water had less impact on a property value compared to a view with a large percentage of something desirable on the property value. So property values in themselves, this is something I had to take into consideration, are composite and heterogeneous. This means that I had to look at all sorts of variables: environmental, structural, neighborhood, which I'll discuss again later, location, view, all sorts, and then filter through those variables to decide which ones I could actually feasibly collect and use those in the economic model, which I'll discuss later. And then location and access, location and access are also, they're very well similar to view of forest land, so that's something I have to look at. Thorns and I cited in Cavalli's found that forest access does provide property value increase, so is it the access or the view that's actually providing the property increase? That's something to discuss. So this is my study area, Portland, Tompkins, and Tioga counties. If you see the brown there, those are the single-family year-round residences within 8 miles of a state forest. 8 miles was the bounding limits of my study area. On the left, that's the private forest. On the right, that's the New York State DEC State Forest. So as you can see, the area is very well forested. So part one of my thesis was to construct a viewshed model that calculates the percentage of view. That's my environmental model. Part two was to use a statistical model to understand how each variable affects the selling price of a property. So the economic model at its very, very, very basic level is selling price is equivalent to the environmental, structural, and neighborhood variables. And this is a picture taken in Tompkins County. This is kind of a typical view that you might see with the rolling landscapes and hillsides. You have quite a distance into the view that you can see. We're cutting it off at 8 miles because 8 miles comprises the foreground and the middle ground. We don't really want to include the very far background that gets hazy and that probably doesn't affect the value of a property very much. I used ArcGIS Model Builder to build a viewshed model. The blue, keeping with Model Builder, the blue are the inputs, the yellow are the tools. And so very simply, what I did was I took my parcel layer, ran it through my model, so you just follow it here. Feature to point, viewshed, then go up. That's where I run the zonal statistics to figure out the percentage of the view that's within a New York State DEC forest land boundary. And that's an ephemeral table, so then I had to do some extra work on it, table to table, to make it a DBF file. That gets saved in a DEC folder that I created. I had to add a field and then calculate a field as a %n%, an inline variable. And I did all of this in an iterator. So this whole model is going one at a time for each feature. Each feature is being processed one at a time, so that this inline variable will create a new column where the feature now has an ID, a unique identifier that's correlated with the FID in the original table, so that I can join the outputs to the original parcel table. That was like a month of work, figuring that out. Okay, great. So then I had to merge and join, and my results showed that 508 parcels have views of New York State forests, and I ran a preliminary test which did find that forests were positively correlated with property values. I need to run more tests to see if the same holds true for DEC lands. And this is a map of the parcels with a view, and you can see there's a little bit of clustering around urban areas, so there's a lot to tease out with their economic model.